section 8.4, triangle proportionality theorem. So the first triangle proportionality theorem we're going to look at is if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So if I know that DE is parallel to AC, then I could take the length of BD over the length of BA and set that equals the length of BE over the length of EC. So really what I'm doing is I'm creating fractions exactly how they look in the problem. So if I had values here, A, B, C, and D, A over B would be equal to C over D, exactly as it appears. If the triangle was turned the other way, and we had the values, I can still make it as it appears, A over C and B over D, all right? So it doesn't matter if I'm sideways or straight up and down, exactly as my fractions appear is how I'm going to make them. The converse is if I can show that the two fractions are in fact equal, then I can say the lines are parallel, right? So they might ask you, are these lines parallel? And we're going to check to see if those two fractions are equal by setting them up and either reducing them or cross multiplying them. So my first problem, find the value of x. So 14 is over x and 12 is over 15. So 14 over x equals 12 over 15. So I'm going to cross multiply here, right? 12 times x equals 14 times 15, and I get 210. And if I divide both sides by 12, I get 17.5. All right, decimals are definitely allowed. We're going to have some funky decimals happening, and that's okay. All right, the next one. I always want the pieces, right? Here I have x and 36 two separate pieces. I can make a fraction that's x over 36. But on the other side, I need to know what this piece is. So if the whole thing is 55, and we know this much, if it was 45, I could put 10 here, right? 55 minus 45 is 10. So my other fraction is 10 over 45. So cross multiply, we get 45x equals 360, and 360 divided by 45 is 8. Okay, next example, right? 30 is over the x plus 7, 25 is over the 15. When I cross multiply here, I'm going to make sure I stick that in parentheses. So 25 times x plus 7 equals 30 times 15. Distribute 25x, and then 25 times 7, we get 175. And 30 times 15, we get 450. So I'm going to minus the 175 from both sides. So 25x equals 275. And if I divide both sides by 25, I get x is 11. So go ahead and try the next three. Pause. When you're ready to see the answer, hit play. All right, so I had x over 18 and 56 over 21. I got x is 48. I had 7 over 6 and x over 21. I got that by doing 27 minus 6. Get x is 24.5. And then 6 over 21 and x minus 1 over 3x plus 1. I had to distribute on both, right? And I get x is 9. So now it's asking determine if the lines are parallel. So we're going to check to see if those two fractions are in fact equal. So the whole thing here is 54. That's already 24. So subtract them, we get 30 here. So I have 30 over 24. I have 37.5 over 30. So what I'm going to do is I'm going to see if they're equal. And I always think the easiest way when I have those two fractions is to cross multiply. So 30 times 30 is 900. And 24 times 37.5 is 900. So they're equal. So yes, they are parallel. All right. Here, I'm going to take 15 over 18, 4 over 5, and check for equal. So 15 times 5 is 75. 18 times 4 is 72. Not equal. No, they are not parallel. So you go ahead and try this one. Pause. When you're ready to see the answer, hit play. All right, so I get 154 equals 154. So yes, those lines are parallel. So here we have a shoe rack. The length of BA is 33. Smaller. Rating 33. The length of CD is 27. CD is 44. And DE is 25. So we want to know if that is parallel to that, right? Is the actual shoe rack parallel to the ground? So if I put 27 over 33 with 44 over 25, 27 times 25 is 675. 33 times 24 is 1452. That's a big old not equal. So no. All right, and our work is our justification for why or why not. So working off of the triangle proportionality theorem, if I had multiple parallel lines, if they eventually connect here, right? We really made one big triangle. I have multiple parallel lines and then two transversals, then I can still say part here over the part here equals the part here over here. So we're still making two equal fractions and cross multiply. And again, if my parallel lines go this way, I'm still going to make the fractions like this, exactly how they appear in the picture. So if this whole thing is 32 and that's 18, subtract we get 14. So 27 over 18 equals x over 14. Cross multiply 18x equals 378. Divide both sides by 18, and I get x is 21. All right, my fractions look like they go like this. So 2x plus 2 over 21 equals x plus 3 over 5. Let's stick both of these into nice big parentheses. So 12 times 2x plus 2 equals 21 times x plus 3. So that's 24x plus 24 equals 21x plus 63. So we'll subtract 21x. 3x plus 24 equals 63. We will subtract 24 from both sides. So 3x equals 39. And when I divide by 3, I get x is 13. So go ahead and try the last two problems. Pause. When you're ready to see the answer, hit play. All right, so for the first one, 92 minus 28 is 64. So we have 28 over 64 equals 31.5 over x. We get x is 72. For the second one, I have 24 over 18 equals 3x plus 1 over 12. Make sure I distribute that 18, and I get x is 5. And that is triangle proportionality theorem.